Hi guys, this is Mrs. Lyons. Today we're going to continue talking about chemical equations, specifically how we balance chemical equations. And before we get into balancing them, we have to understand that there's a reason why we balance chemical equations. And the reason is called the law of conservation of matter, which says that basically matter cannot be created or destroyed. And what that means for us in terms of our chemical reaction, we know that we have reactants, they react to form products. What the chemical law of conservation of matter means is that the number of atoms in the reactants must be equal to the number of atoms in the products. Which makes sense because we said matter cannot be created or destroyed. So if we put in a certain number of atoms, that same number of atoms has to come out on the other side. Alright, that's why we balance equations. Let's look at what it means to balance an equation. Okay, this slide shows how to balance by inspection. And a couple of things, I guess. First, we need to define this little number down here behind an element we call a subscript. And that subscript refers only to the element immediately behind it, or if we have a polyatomic ion, the elements that are in parentheses. These lines in front of each compound or element, we can put a number in, and when we put that number in, we call it a coefficient. And our goal is going to be to put coefficients in each of these blanks until we have the correct number of atoms on each side of the equation. So what we're going to do initially is we're going to count up the number of reactants and the number of products, the number of atoms of reactants and the number of atoms of products on each side of the equation. So carbon, if we look, we have carbon right here. In our reactants, we have one carbon atom. Over here in our products, we have a carbon. We again have one carbon atom. We're going to look at hydrogen. In our reactant side, that's on the left side of the arrow, we have 4 hydrogen. On our product side, we only have 2 hydrogen. Oxygen, in our reactants, we have 2 oxygen. In our products, we have 2 in the CO2, and then we have 1 in the water. So we have a total of 3 oxygens. Okay, now we're going to learn in a little bit after finals, we will learn that these are a special type of reaction called combustion. And in a combustion reaction, we always start out with a carbon compound. We always end up with water and carbon dioxide. There's something really important. There's a way that we can balance these that helps us get them done quickly and consistently right. And that method, I call it the CHO method, C-H-O, and you'll notice this is lined up C-H-O. These are the order that I balance in. So if I look, my goal is to get the same number of atoms of each element on both sides. So carbon is already balanced. I have 1 in my reactants, 1 in my products. Hydrogen, however, I have 4 hydrogens in my reactants, only 2 in my products. So what that means is I have to put some number, a coefficient here, that will give me enough hydrogens so that they're balanced. Now if I put a 2 here, now I have 2 times 2 for a total of 4 hydrogens, right? Now notice what I also did there though. If you remember, this coefficient is going to multiply by the whole compound until we get to the plus sign. So not only do I have 4 hydrogens, but I also have 2 oxygens here for a total of 4 oxygens. Okay, so let's look. Our carbon is balanced, our hydrogen is balanced, our oxygen is not balanced. I have 2 on the reactant side, 4 on the product side. So I need to put a coefficient in front of the oxygen. If I put a 2 here, 2 times 2, now I have 4 oxygen. So my oxygen is now balanced. So I have the exact same number of atoms on each side of the equation. Now, if there's not a number in front, we're just going to assume it's a 1 and we're going to write the 1 so that we have a coefficient in front of each compound or element. Let's try another example. All right, this example, this example has a polyatomic ion in it. Okay, and again, we're going to make a table of the elements. However, if we have a polyatomic ion on both sides of the reaction, we don't have to separate out the PO4. See, we have a PO4 here, we have a PO4 there. We can just write it in our table as PO4, and then we can count how many phosphates we have. The other thing to keep in mind is that when we see water, sometimes an OH is hidden in the OH, in the water. So if you look here, this is actually, it's H2O, but we're going to separate it out as HOH because here we have OH and on this side we have OH. Alright, so let's count up what we have on each side. Hydrogen. In our reactants, remember we're not going to count the hydroxides, we're just going to count hydrogens, so we have 3 hydrogens in our reactants. In our products, we're only going to count the single hydrogens. In the products, we have 1 hydrogen. PO4s, so we want to know how many PO4s do we have. On the reactant side, we have 1. On the product side, the subscript 2 tells us we have 2. Calcium, Ca, we have 1 on the reactant side. On the product side, we have 3. And then finally, hydroxide. On the reactant side, little subscript 2 outside the parentheses tells us we have 2. Over here, the OH, in the water, we have 1. So it looks like there's a whole lot of balancing to go on here. Not much is equal yet. But we're going to kind of start, and it doesn't matter where you start, just pick something and start. Okay, so I'm going to start with hydrogen since it's at the top. I have 3 hydrogen over here. Over here I only have 1. So I need to get 3. I can do that by putting a 3 there. That gives me 3 hydrogen. Remember, we have to consider what else it affects. It also affects those hydroxides. So I'm going to go down here and I'm going to change the 1. I no longer have 1 hydroxide, I have 3 hydroxides. Alright. What about PO4s? PO4s, I have 1 over here. I have 2 PO4s over here. So that means in order to get this to equal, I have to put a 2 here. Alright, so now I have 2 PO4s. But what else did I change? I changed the hydrogen. So remember it's H3. So now I don't have 3 hydrogens, I have 6 hydrogens. Okay, so I'm kind of going backwards here. If you notice, I've got my PO4s to equal, but what happened? I've now got 6 hydrogens and 3 hydrogens. Let's just keep going and see if we can get this to work out as we go. Calciums. I've got 1 calcium in my reactants, 3 calciums in my products. So I'm going to have to put a coefficient of 3 here. That'll give me 3 calcium. How many hydroxides?